Hello and welcome. We've got a Vox AC 30 and it's in for blowing fuses, so we need to open it up and take a look at it. This thing is huge, as they are, and it's quite heavy as well to get up onto the bench, but we've managed it okay. So we'll have a bit of a look, we'll get the back off and see if we can see what's wrong with it. Customer says that he purchased this amp in the early 90s. He had it serviced about 10 years ago. So it'll power on, but as soon as he applies the standby, it blows the fuse. So we probably, first port of call is probably to look at the rectifier and then look at the output tubes to start off with. Can't see any evidence of anything being burnt in there or anything. Right, we've got a Softec 5AR4 GZ32, so we'll test this and just see if it shows up any problems on the tube tester. Right, I've just checked this GZ34 on the tube tester, and on one side I get a reading of good, well, reasonably good, but the other side tests bad. So that's the first port of call, I think, is that GZ34. So what we will do is we'll put the amp on the bulbs and we'll put a solid state rec here and see if it fires up. And then we can check the amp over as well, make sure everything's working okay. I think that's the best plan of campaign. I think I'll get it out of the cabinet as well, because it's awkward to work on while it's in there. We can have a good look at the tubes and everything else. Right, we're just testing these tubes, these JJs, and you can see we just clip on there. You can see that the white paint, the red paint's going white, which is a sign that these tubes have been grilled and they are running way over bias. So I'll put this one in the tester. I've tested the other three, and they're all giving me roughly around the same results. We've got no shorts, but we'll give this one a test. Yeah, and you can see, so they've just about gone into the green. Now this tube tester reads about 5% low, so it's probably just about 60. The others are slightly worse than that, but they are just hitting the green. So that tells us that these tubes have been over biased. Now that's, whatever's wrong, they've been running like that for some considerable amount of time, because they're all white. So usually where you find lots of current, and they obviously have seen lots of current, what you usually find is that there'll be a short appear sooner or later, and that's exactly what we've got here. We've got a short. So here's the rectifier tube again. So we want 8D1. And the tests are 4 and 6. So if we swage him in here, like so, let me just pull the camera back so you can get a bit of a clearer view of it. So if we put 4, let's use 4. Now, when we're testing the diode, we're looking at the lower part of the dial where it says diodes OK there, and you can see that that is it's just got on there. But that side's testing okay. So we're not using the top part, using the bottom part. So if we go to 6, and you can see when you do that, that's testing bad. Now it's not testing shorts, it's just testing bad. So as this amp been running at excessive current, this has just got tired, and then these have been running at excessive current, and one of them has caused it to short. So we're going to have to do a few tests. First thing we'll do is check the secondary winding on the transformer to see if it's short. But so far, what I'm seeing in this amp is excessive current with the paint on these. It's a dead giveaway, and that's really tired. You don't often see these really tired, you know. It's very rare, these GZ34s. They last years, so something's not quite right. So we need to see if we can find out what is wrong. Right, so I have a bit of a test around. So it's the primary fuse that's blown, the power on the power side on the wall at voltage that's blown, and it's rather black inside as well. So let's just check what we got there. Yeah, that looks okay. Let's try this. Yeah. And here, let's join this and there. Yeah, that looks okay. So let's check the secondary. We can do that here. 69 ohms, that looks okay. That's the filament one, that looks okay. But the filaments are fused, so if there was a problem there, you'd think it'd be blowing the fuses in on the board here. So that tells us we've got no shorts. Let's stick this rectifier tube in. Which doesn't show that there's any shorts on the doesn't show with any shorts on the meter. But if it's blowing it immediately as soon as it's turned on, then maybe if we plug that in there, it might now show a short. So we'll look. Nope. No, so that's not changed. So let's try from the other side of the rectifier side. Nope, nothing there going on there to shout about. Right, I've got a schematic here, so we can have a look at that as well. And I think this is the correct schematic. Looking at it, and this is from 1992. So now we can look at a few. So I'm just looking where I've checked a few components out and matched them up to the some of the numbers on here. So for example, if we look at screen resistors, which are 100 ohms, so if we let's just zoom in a bit if we can, just hold that still. So if we look, you can see R73, R79, R77 and R75. So if we come, you can see them here. Getting a bit of glare off this light, but I can see them. It's R75 and so on, R77 and R79. There R73 here, you can see that one. So that's telling us that this is probably the right schematic. The more parts we find, that the numbers match up for the better. Now, looking at the bias, this amp's cathode biased, looking at the cathodes, you can see we've got 100 ohm resistors. We just go in. Where are we? We need to be there, don't we? Tap that so we can get in focus. There we go. So cathodes here, you can see if we come across, and you can see we've got 100R and 100R, R70 and R71. So if we look in here, and they can, you see those there, but they're actually 200 ohms. Or are they 100 ohms? And that looks red, but it's brown. I think they are. So we need to get the meter and test those, and those are indeed R70 and R71. So let's test that, because at first glance they look like 200 ohms, but we'll get the meter up, and we'll have to back out now. We won't get everything in shot. Well, that says 50 ohms. So they must be wired in parallel then. And if we look there, you can see those two are wired at the same point there to the cathodes, and then the other sides are on the ground there. So you can see they are indeed wired. So 50 ohms, no wonder, it's no wonder this amp's running hot. So those need to be increased, I can tell you now. So those tubes have been baked. And it just seems like they've been put in and just the bias has just not been checked. So the customer had this amp service, as I said, 10 years ago. And he had the tubes put in 10 years ago. But he only uses this amp for when they rehearse. And he says it's not had a lot of use. So 10 years sounds a long time for a set of tubes. But if you're rehearsing for 3 hours a week, so 50 weeks of the year, over 10 years, that's only 1,500 hours. And really, if these tubes are set up properly, he should get much more than that out of them, much more. If they're being abused, you won't, but if they're set up properly, more like 5,000 to 10,000 hours. But although modern tubes don't seem to last as long as new old stock tubes. But anyway, enough waffling. So what we need to do now, I've took the tubes are all out of it, and I've got a solid state rectifier in it. I've just popped that in. So what we're going to do now is we're going to fire this amp up on the bulbs, and we're just going to check to see if what sort of readings we're getting and what sort of current is being drawn on this amp. So we've got a meter here, which we're going to use for testing. So we want to be testing for HT voltage, see what we've got on the anodes and things. We'll test, let's test the output transformer as well before we go any further. That would be a good idea as well. So let's see, we'll come around this side of the camera here, and so looking for center top. We've got the anode. We're on, oops, bring that in shot. We're on anode there, 56. Okay. So let's go on to the other side. Anode. 55k, 55.5. So that's a pretty good match, and that tests out okay. So that's all looking good, isn't it? So there's no that looks pretty okay there. So we'll start with a 40 watt bulb. Let's just switch on. That's okay. Let's have a look what we've got. 247 volts there, and we've got 151 going in. So that seems about right from what we've got going in to what's coming out. So that's looking okay. Screen resistors 244. Any screen resistors blown? Those two aren't blown. Let's check the others. No. And let's check the other one, which we just have to move the meter across to get to it. Screen resistors are all intact. They're not open or anything, but then we'd have less current, not more. So we check them anyway. We check everything. All's looking good. The bulb's dim. 40 watt bulb is dim. We're drawing 90 milliamps. We don't have the output tubes in, but we do have the preamp tubes in. 90 milliamps. And you can see that up on there. If we go in, you can see that up on there. You can see 90 milliamps. 151.6 there. We're drawing 14 watts. So nothing major's going on there, is it? But it's when we load, you know, when we load the transformer up, the power transformer, then we'll see. So we've got the solid state rectifier in. So what we're going to do now is we're going to put the tubes in. But before we do that, we're going to check and see if this voltage is disappearing out of this amp, because we've not got no output tubes to dissipate, to remove it when it's switched off. And it is going down now, down to 24, 23 volts and dropping. So that's okay, that's going down. So what we know so far on this amp is the rectifier tube, the GZ34, is shot. The output tubes have got a bit of life in them, but they're not wonderful. But we still don't know whether it's one of the tubes that's blowing the pink. Go away. We've got voltage. You're not allowed on the bench. One of the output tubes, whether it's blowing the fuses when it's under load, whether it's got a short inside. It's not showing on the meter, but then they're not tested at high voltage. So that's where we are with it. So we'll get these tubes back in now, and we'll power up on the bulbs, and we'll see what we get. We need to be very careful what we're doing with these tubes. And we need to remove Pink off the bench. You can't see her, she's just off camera. But she's going to have to be removed, because we can't have her up there when there's high voltage. So we switched on and we're drawing 120 milliamps, but remember we've now got the filaments in from the output tubes, and we just need to go up to a bit bigger bulb now. So let's take out that, put in a 60. So we've got a 60 watt bulb. We've got 217 volts going into it now. So you can actually, and it's dropping because of it, obviously. And you can see that there. So we'll bring this meter back up here. We've got a speaker plugged in. So let's see, let's just see, put that in there, and Let's see if we've got any conductance on the cathodes. And yes, we have a little. You can see there. So let's just bring this up steady now. There we go. So we've got a bit more. Yeah, 1.2 on the cathodes there. Across the cathode resistors. I think we have got a bit of sound. I'm just plugging in the signal generator, but I think we've got something going on. So we're up and running. So we can go on the bulbs a little more now. We'll go up to 100 watt bulb. You can see that's, you can hear that coming up now. And on the brilliant channel there, let's turn that down. So we've got 150 volts going in, and we've got 226, we'll go on that plate. 226 on that plate. So that seems about right. Stick another 40 in. We'll come up a bit more. And you can see now we've got, that's dropping again because the tubes are now starting to conduct more. 42. Oh, sorry, 4.2. 4.25. Drawing 310 milliamps off the wall now. So go up a bit more on the bulbs. Just being very careful, because in case we happen to see anything that doesn't look right, i.e. the current going up suddenly on the wall meter. Drawing 55 watts. We're now up to 255 volts. You can hear it's just got a bit louder again as we get more plate voltage. Just turn the volume down. 340 milliamps now we're drawing. Right, let's put, now I've got 200 watts of current limiting. The bulbs are dim, but they are lit. 182 going in, and we've got 270. I can see it at the top, but if we pop it on there, you can see 267. We've got a bit of a drop across the output transformer of 3 volts. But right, so I've gone on to the dummy load now, so we know we've got signal. So I've just popped it on the dummy load, so it's quieter. Does get a bit annoying that all the time. We've now gone up to 390 milliamps, and if we just go up there, you can see 390 milliamps now we're drawing on a couple of those 100 watt bulbs. I'm just looking at the tubes. Do you know, one of those tubes looks like it's going to air. I don't know, the getter is disappearing off one of them. Right, so let's go up another 50 watts on the bulb. And now we're up to over 300 volts. Now remember, we've got a solid state rectifier in this, so we've got to be careful, because the bias, obviously we know by looking at those tubes, the bias is already high in this amp, and that rectifier tube will probably give us another, I don't know, 40 volts maybe, I'm not sure, but we need to be careful. Now we're drawing 500 milliamps. So you can see we've got 250 watts of current limiting there. You can see the bulbs now, they're dim but they're still lit, but they look a lot dimmer off camera than on. We've got 205 going into the amp, You're drawing 500 milliamps. So yes. So about 304. So while we've got that now, let's come back down. So while we've got that now, let's look at the bias. I know we're on the bulbs, but yeah, 8 volts. And we've got 50 ohms of resistance, haven't we? 8 divided by 50, that's giving us 160 milliamps, divided by 4, that's 40 milliamps a tube. Won't worry about the screen, we're only looking for a window, so not going to take the 5% off, and times that by 304. So they're at 12 watts already, and that's with the bulbs on and only 204 volts going into it. They're already at 100%. So I'm just going to put another 50 watts of current limiting in it now and see where that takes us. That takes us up to 220 volts. 219, 220 volts going in, and we've now got 328 volts of plate voltage. We're now drawing 550 milliamps. Let's check again. 9.22. So the tubes are drawing 46 milliamps now each. Times 327. So they're now running at 15 watts. So we'll have one of those bulbs out. They're running at 15 watts. And that still wasn't full wall voltage, that was 220 volts. So that would probably be round about what the GZ34 was giving us. So we can't run this amp permanently on a solid state rectifier. There'll just be too much plate voltage for this amp. It'll be too much. And bearing in mind, by the time we've biased it correctly, we'll have even more plate voltage because it's running so hot. So the problem was with this amp is that when this amp was serviced, the bias wasn't checked properly on this amp. The tubes were just thrown in, and it's that same old thing again. Oh, it's fine, it's a cathode biased amp, we don't need to check the bias. And I'm afraid you do. I've seen this time and time again with amps. You know, it doesn't matter whether it's cathode biased or fixed bias, you check the bias when you put the tubes in. You know, these JJs are obviously drawing more current than the tubes that was in it previously. So yeah, seen this time and time again. We've proved it time and time again by putting different tubes in amps when we've done videos, different types of tubes. You know, we've put JJs, we've proved it with the Russian tubes. You know, you put the Russian tubes in, they draw far more current, some of them. So yeah, I'm afraid that's what's baked those tubes, because those tubes would last years otherwise. And you know, if the guy's used it over 10 years and he's done about 1,500 hours, that's nothing. You should be getting 3, 5, even 10,000 hours if they're biased. You know, if they're biased cool, you'll get a hell of a lot out of them. So the amp's running. We now know we don't seem to have any shorts or anything like that. We've just got high bias. I don't want to put that rectifier tube in. To be fair, I don't want to risk putting that in and just seeing if it blows the fuse, because it's we don't want to risk that transformer or anything, and it's not the way to test things. So the thing is, we know that rectifier tube's rubbish anyway. We've tested it and it's bad, so there's no reason to put that back in. These tubes, you know, so far they're not showing any signs of red plating or anything from what I can see looking, but then we are still on the bulbs. So 250 watts of current limiting is setting this amp at 12 watts of bias, 100%, and that's with a 204 volts going in. 500 milliamps we're drawing there at 94.3 watts. So that's where we are with things. We need a new set of output tubes. The amp runs okay. We've got no shorts. The transformers seem okay. Don't seem to have any problems. Flick standby on. And bearing in mind now I've only got a 680 milliamp fuse in there instead of a 2 amp. But then again, you see, when you flick the standby in, the bulbs will absorb any, any surges in current. The bulbs will take it. So again, you could do that 50 times and the fuse won't blow. Let's turn his attention to the caps, and that's better. Let's turn his attention to the caps and the gubbings in the amplifier. So we've got a cap here that's bulging, so he's going to have to go because he's going to vent his spleen soon. Not sure what's gone off with this one. This here, we've got an axial there that's been glued to the side of this one, and there's a cable disappearing off down there in all this gunk and whatnot. We've got shrink tubing put over this to prevent the case of this touching, because it's touching on the fuse. So if we just go in, and you can clearly see now it's touching on the side of the fuse there. So if the insulation failed on the capacitor, then that would be a dead short. So that's why that's been put over there. It's also not in straight, which I'm not quite sure what's going on there with that. We're going to have to dig all of that out. So this amp needs a recap as well. Definitely. There's no way I'm letting this go out like that, and this needs the proper capping. And I think what's going on here is that, this capacitor is just too big. It may be the right values, but they make these in different sizes and so on, and that's just a bit, it's almost like, well, I've got a 47 at 500 or 450 or whatever. It must be probably 500. Let's have a look on here if it says what it is instead of speculating. At 450. There, 47 at 450. So probably had a 47 at 450, but it was probably, let's just flick that, it was probably a just a bigger case on it, and so rather than ordering the exact one, they've just made it fit. And they've probably been able to get away with doing that by putting this axial in there, which is thinner, which has allowed it to go between the fuse and the other cap. So maybe the other cap was a bit wider like that, and it probably wouldn't have quite gone in there. So is that why they've done that instead of just ordering the right sizes? And then you finish up. I mean, don't get me wrong, everything's solid. There's nothing, I mean, you can see it rocking the amp. It's solid enough. There's nothing dangerous going on there. There's no way that's ever going to get through that insulation, but it would be risky leaving it with the normal insulation on the cap. But so I'm not looking at that thinking, whoa, that's dangerous. It's not. It's just not a good look, and you just really shouldn't have that butted up against the fuse. And this should be a radial, not an axial. I think that's a 33, that one that's bulging, if I remember. I think I had a bit of a look at that. Yes, 33 microfarad. This one's 22 here, and I can't see the numbers on those, but that is C36. 22 microfarad for the screens there. You can follow that up, and it goes up all the way up there, goes up there, and you can see it's come to the screen. Speaking of the screens as well, just click that again. Speaking of the screens, 100 ohms for these screen resistors is too low. We need to increase those as well. That's way too low, which is another reason why those tubes have had such a pounding. Right, I'm taking this board out, and pretty easy, usual deal. You take the knobs off and the sockets, and then we've got these plastic things here. Unfortunately, this one, when they put all this silicone round here to glue this crooked capacitor in there. They've also glued up the plastic release there on the board. Oh jolly. You can see that there, so we're going to have to dig all that out. I just want to see what's going on under this board before I get a bit of a parts list up. I want to see the fact that this cap's leaning like it is. I just want to see what's going off under there. Yes, we're going to have to dig that out of there because we're not going to be able to get, in fact that's not silicone, that's hot glue. It is, yeah, that's hot glue. So I think it's hot glue. We're going to have to use the heat gun to soften it up to get that off, I think. Oops, I've still got the current limiter on. There we go. That's gooey. It is. That's definitely hot glue. That's free, I think, or free-ish. Let's see if we can release it now. Yes, that's better. We can release it now. And we've got one more to release somewhere, and I'm struggling to see it because I'm trying to hide around the camera and not get in front of it. All you'll be able to see is my bonds. That's my head, if anybody doesn't know the slang of that. So what we're going to do is get this board out, tip it back. That's what we want to do. We may have to solder that wire off because we may not be able to push it far enough back. There we go. So that's that. That's there. Got those off there. We may not be able to push it far enough back before we lose the slack on that wire. So we're just going a bit steady at the minute. Looking at what we can remove. So that's that. What we got here, slack on there, still slack on there. Right, I think we're just about there. That had snapped back in. Could probably see it on the camera. There's so close. I've disconnected the ground over here. You can just see to the star because that's not going. That's under the switches. So when I try and lift this board, tip it over, that's not going to let it go, so that's had to come off. So we are now, I think we can just do it, can we? Yes, can we? Yes, we can. And there we go. So that's lifted it. There's the ground. You can see it's put the ground there. So let's just have a peep underneath and see. Looks all right. Let's see if we can tip this completely over. So we've got to watch the cables, what we're doing. So you can see, for instance, here, so you can see let's just go back. So you can see as we start to lift this wire here, look, just begin, you can just see. So before we pull it too tight, you just have to watch for that when you're lifting them. It is not to not to yank on them. So we need to unsolder that, and the way they've done that is you can see it comes up there and loops through the board. We just go in. You can see it goes up, loops through the board, and then connects underneath, and that's going through to the transformer. So you've got to hold the board up without pulling it too tight, and then what you've got to do is unsolder it and then pull it out, because if you yank on that and it comes out of the transformer, it's all over. So in actual fact it will stand up with that, And there's you can see, if we just go up, you can see that there is plenty of slack in it, but I might still disconnect that. There is a, oh actually no, that doesn't go to the transformer. Duh, that's my eyes again. That goes to that socket there. So, but unfortunately they've connected it, they've fastened it around the transformer wires, so there's still potential to pull those out. So I think I'm going to cut that, and I think we'll be all right. Yes, there we go. And the other one's attached to it as well, so I think we'll cut that one as well. Then we're not pulling on those cables, because that's the last thing we need to be doing. There's enough things wrong with this amp. There we go. Now there's no risk of damaging that, pulling that out, and we've got the board back. So that's where the cap's been put in. You can see down there. Let's see if we can get a bit more light on. And there we go. That's making, the trouble is when I put that light on, the aluminium makes the well, the steel, it's actually steel, makes the camera flicker. But yes, you can see there where that's gone in. So there's no problems there, no problems with the traces. I can see these sockets look okay. Don't see anything wrong under there at a glance. Nothing that's jumping out saying, whoa, that's a problem. So yeah, those tube sockets are really good as well. That it took a bit of heave-o to get those out, get the tubes out of the sockets. So the sockets are good, so we've got no problems there. So although they soldered into the board, they're good quality. This amp really, it looks brand new inside, doesn't it? It doesn't look like it's had a lot of use. And the guy says he's not really used it a lot. Yes. So I think I'd like to get that capacitor out of there and all get rid of some of this mess here, and see what's under there, what we're faced with. I'm hoping that the only reason it's like this is because he just didn't have the right part and just didn't want to wait to order it or whatever. But my days, this is something you don't need to be doing. That's going to be fun and games getting that lot out of there. Oh dear, oh dear. There must be 3 tubes of silicone and 4 sticks of hot glue in there. Right, let's see if we can get this out. I get most of this solder off because, yeah, that's not bad, because it's been bent over as well. The lead is bent over. Never good when they bend the leads over. Right, so what I've done is I've got most of the solder off the lead that was bent over, and then I've snipped the lead back, and I've done the same with this one now. So I'm just going to try and get a bit more solder off it. Allows me to get the nozzle of the soda sucker over the lead now as we're cutting it. And that's not too bad. So let's remove that. I'm pulling clumps of this out. Let's see if we can get this capacitor out, because this is just a mess as well. Get rid of that. Let's see if we can get this capacitor out, and that will make it easy to get some of this crap off of here. We've got one lead to get out of there now. Let's have a look. Right, the battery went on the gimbal there, so I've got a bit of charge into it and carried on a bit further. I've managed to get out another clamp there. So yeah, and now we've got this loose, this cap-ish, so we're going to see if we can get it out now. What he's done there is folded it under the capacitor, and I'm actually thinking, looking at the line of the capacitor, that it's this terminal here, but it's not. It's actually this one. And I was thinking the wire that he's brought down would be that one, because the wire's in front, but no, it's not the case. I don't know where he's put that other wire. No doubt find out later when we get all this mess off here. Right, let's cut this lead off now if we can. Just cut the bit that we've cleared the solder from. I think that's the right trace. So, dear oh dear. Five past 12 at night now. We're on the night shift. Oh dear. Oh dear, look at that. Gumption. I think it needs some gumption on it to clean it up.
Gumption, 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 gumption.
I need some alcohol on it eventually to clean it up, but we haven't got past the shovel stage yet. I just don't want to break the board. Got to be very careful. Have some patience, because let's try and cut through that a bit. Plus it's stuck to wires and all sorts. You're pulling a wire out the board if we're not careful. See, that's the other thing, you know, these glues, they've really bonded to this shrink tubing that they've put over here. This is what's making it hardest to get off, so we might try and cut this, see if we could cut it. Oh dear, this ain't, let's just get some support under that board, keep those pots off the edge of there. Right, let's soften this shrink tubing up. It looks like that type of stuff. Looks like a type of stuff with the glue inside it, so as well. Days. I'm getting a bit burnt. Wow, that's hot. Right, let's try and cut down the back of it now. Right. That thing's huge. 47 at 450. This is why when you go on DigiKey or Farnell or CPC and you look down the list and there's all these caps listed at the same microfarad and the same voltage, the only difference being they're all in different sizes, and that's the idea of doing that, so you get the right size, and instead of doing all this and botching it up. But getting this off, we'll get the gun on again. Oh dear. Hoo-hoo. By them fuse how just red hot they are. Keep catching my fingers on them. By gum, they're burning me. Oh dear. Right, let's see now if we can shovel a bit more of that hot glue out that's around those wires, and I've got to be really careful. They're the filament wires. It's not what you want to be doing when you've got arthritis in your thumbs. I've got that off anyway. Ain't pleasant. And more, that's getting even looser now. We're getting there. We're getting there. Hey dear. You've got to have patience when you're doing this, because if you really go at it and you risk damaging the board. And there we go, I'm getting underneath now. I think I'll get to the other one. There we go. And there we go. There's our friend, 47. And he's a Nichicon, you know, he's not used, it's not like he's put rubbish in there. Put good caps in, they're just the wrong size. There's a resistor there. Things are appearing all the time. First time that's seen daylight for 10 years. So we've just got to clean all that mess off there. So I wanted to get that out because I just want to get a diameter for when I order these caps. What I'm trying to do now is order what parts we need, and to do that I'd got to see exactly what size these were. Need to make sure in fact I might even have a cap to go in there. But yeah, and we've got to dig all this stuff's all run into the fuse holder, and so we just need to get all of that out as well. Right, I've been at it so long now. I pulled the power supply out of the gimbal and it's collapsed and gone flat, and the camera's nearly out of charge. So I'm now holding it in my hand. So we know where we are with this. So I'm going to make this a part one now. And that was boring watching me take that out. And yeah. And this is why you must use the same diameter of capacitors. So what I'm going to do, I'm now going to order all the parts for this that we need. I'm going to get onto the customer first and just let him know what's happening and make sure he's okay with it. And then we're going to order 4 new EL84s, a GZ34, and a full set of capacitors for this amplifier. I'm going to have a look what I've got in stock, and what I haven't got in stock, we'll just order it all, and then we'll just blitz this amp, and we'll rebias it so the tubes last a lot longer. So that'll do it for this one. So thanks for watching, and sorry if I've had a bit of a moan at this, but that was a bit of a pain to do. Thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.